The single most important invention in analog electronics after the transistor is the operational amplifier. The operational amplifier is a circuit block used in various circuits like the filters, oscillators, amplifiers, and to perform mathematical operations. This is Abhinav from learnelectronicsindia.com, and let's learn about Opamp and how it functions. Operational amplifier was invented by Carl D. Schwartzel of the Bell Lab in 1967. An operational amplifier is represented as a triangle with 5 pins, 2 input pins, 2 supply voltages pin, and 1 output pin. The operational amplifier is essentially a differential amplifier. That is, it amplifies the difference between the 2 input pins. Hence, the output voltage is given as the difference between the input voltages times the amplification factor. This amplification factor ranges between 10 raised to 5 and 10 raised to 6. The supply voltages are used to power the operational amplifier. The maximum and the minimum output level of the operational amplifier is defined by these supply voltages. The construction of operational amplifier is very complex. So to understand the functioning better, let's look at an equivalent circuit. The resistance between the 2 input terminals is Rin. The output voltage is the amplification factor times the difference in the input voltage. The output resistance is given by R0. From the equivalent circuit, we can derive the characteristics of an ideal operational amplifier. No current flows through the input of the operational amplifier. Hence, Ri is infinity. The output impedance of an operational amplifier is 0. The gain of an ideal op-amp is nearly infinity. And the bandwidth is nearly infinite. But such ideal op-amp don't exist in real world. Hence, in a practical operational amplifier, the input impedance is very high, of order 10 raised to 5 to 10 raised to 6 ohms. The output impedance is very low, and the gain of the op-amp is of the order 10 raised to 5 to 10 raised to 6, and has a high bandwidth as shown in the graph. An interesting feature of operational amplifier is that the op-amp will try to keep the input pins at the same potential. In a closed loop configuration, it does this by increasing or decreasing the output voltage and thus increasing or decreasing the voltage at the input pin via the feedback resistor. We would be learning about this in detail in future videos. Now let's look at how an operational amplifier looks in real life. Here we have a LM358 operational amplifier designed by National Semiconductors and manufactured by Texas Instruments. LM358 consists of 2 independent op-amps. The IC is packaged in dual inline package of 8 pins. The IC pins are numbered from the indent at the top left corner in anti-clockwise direction. We can get the pin diagram from the datasheet of the IC. Pins 2 and 3 are the input pins for Opamp 1, while pin 5 and 6 are the inputs for Opamp 2. Pin 1 and 7 are the output for Opamps 1 and 2 respectively. An interesting feature of LM358 is that it uses only a single power supply to power both the op-amps. Pin 8 and pin 4 are the supply voltages pin. LM358 is used in various applications like sensor amplifier, audio amplifier, and control circuits. where the op-amp can be used with a single power supply. Another widely used op-amp is LM741. LM741 is an 8-pin DIP IC, but it only consists of one operational amplifier. In the future videos, we will look into various configuration and applications of the op-amp using LM741 IC and a circuit simulation software called Multisim. You can find this entire series about OpAmp at our website link in the description. This is Abhinav from learnelectronicsindia.com and thanks for watching.